Hey everyone, in this lesson you're going to learn how to apply the log properties. So today we'll be covering how to expand logs using the product rule, the quotient rule, and the power rule. So the product rule says that when you multiply, when you want to expand logs, okay, so this is your multiplying x times y, then you expand this log in this way. Okay, so notice there's a plus in between. And when you do the quotient rule, that means you have value or quantity m divided by n, quantity n, with the log base b. So then in this case, instead of adding, the main difference is we are going to subtract. Okay, so when we multiply, we add. So that's the product rule. And when we divide, we subtract. So let's see, and this is a quick example on how to do this. Okay, so notice 7 is in the numerator, 3 is in the denominator. So then when you expand this log, it's log base 2 of 7 minus log base 2 of 3. The power rule. So for this one, all you have to do is bring the power of m to the front of the log to expand it. So an example, quick example is here. The value of k in this problem is 3. So then the 3 comes to the front, and that's how you expand that log. So I'm going to go over these examples real quick. Okay, so notice we have p and q. So this is the product rule. So then this is equal to log base 3 of quantity p plus log base 3 of quantity q. So as you can see, it's very simple and very straightforward. So on the second example, for the second example, we have the quotient rule. But notice that we also have the power rule. So for this one, this is expanded as log base 3 of p squared plus, not plus, this is minus, right? Because this is the quotient rule. So minus log base 3 of quantity q. So then I'm going to apply the power rule. So then this is 2 times the log base 3 of p minus log base 3 of q. And this is the expansion of that problem. So on the next example, we have again the quotient rule, but we have a and b in the denominator, and b has a power. So then when I expand this is going to be expanded as common log, because if you don't see a base, don't forget it's implied to be base 10, so that's the common log of 4 minus common log of a minus common log of b squared. But then I'm going to apply the power rule to this log. So then this is equal to common log of 4 minus log of common log of a minus 2 log of b. And this is the answer to this problem. So I'm going to go back and box in the answer to the previous two problems also. Okay, so this is my final answer. Okay, next example. So for this one, we have 2 and y in the denominator. So this is a product and quotient rule being applied at the same time. So let's expand this. So this is log base 4 of 3 plus log base 4 of x minus, now we have log base 4 of the number 2 minus log base 2 of y. And this is expanded completely. So in this case, we had a combination of the product and the quotient properties being applied. Okay. So for example number 5, this one here, we have 4 times q squared times square root of r. So I'm going to just remind you, let me just remind you of this. Square root is the same as saying r to the half power. Okay, so I'm going to expand that using that right there. So then I have log base 3 of 4 plus log base 3 of q square plus log base 3 of r to the half power. So now I'm going to apply the power property to this one and to this one. So then expanding this further, we have log base 3 of 4 plus applying the power property, so 2 log base 3 of q plus 1/2 log base 3 of r. And this is that log expanded. okay, or the expansion of that log. So let's go on to the next example. So for example number 6, notice we have the power, the product, and the quotient. So let me remind you real quick that for this part, this you can write in as a rational power. So this is R, the index is 3, so 2R to the 2/3 is a power, okay? So then this is going to be the natural log of P to the 4th plus the natural log of Q to the 5th power minus the natural log of R to the 2/3 power. Okay, so then I'm going to apply the power rule. So this becomes 4 times the natural log of P plus 5 times the natural log of Q minus 2/3 natural log of R. Okay, so I was going to write 2/3 again, but this is just R. So this is the answer to that problem. For the next example, we have 2 here. We have a 4. And we have this quantity here, x plus 2, and it's being cubed, so we're applying the product and the power. So this is going to be expanded as the common log of 4 plus this will be the common log of x plus 2 cubed. But then I'm going to apply the power property here. Don't forget, it fits inside of a parenthesis. You cannot do anything else. Okay, so this is just one log. So this is equal to common log of 4 plus 3 common log of x plus 2, and that's all for this problem.